Dear friends and students, I am Nakul. Welcome to Math Study Center. From thumbnail, you already know what I will discuss in this video. I have discussed every section very well. There are so many important examples, there are so many important exercises in this video which will be very helpful for all of you. So watch this video from first to last. If this video helps you even a little bit, give a thumbs up, leave your comment and share this video with all of your friends. Okay, let's start our discussion. Well, in the chapter of quadratic equation, these are two things which are kept in your class 11 as well as joint entrance examination syllabus. I will explain them one by one, but before starting discussion, I want to mention three things. Number one, watch this video at least in 720p and 1.25x speed so that you need a little bit less time to finish this video. Number two, all the contents of this video has taken from NCERT, R.D. Sharma and many other books. Number three, everything I will discuss has already written down on screen. I will just explain them one by one. So read them and just follow my explanation. That will be enough. Okay, let's start discussion one by one. First, I will discuss concept of quadratic equation, that is introduction. We know fx is equal to summation of I is equal to 0 to n ai x to the power n minus I is equal to 0 is equation of degree n. If we take value of n is equal to 2, then this equation will be the quadratic equation, and we can write down fx is equal to summation of I is equal to 0 to n is equal to 2 ai x to the power n minus I is equal to a0 x square a1x plus a2 is equal to 0, where a1 not is equal to 0. This is necessary condition. This can be written like this: ax square plus bx plus c, which is the general expression of quadratic equation. Now if alpha beta are two roots of this quadratic equation, then these two relations we have: alpha plus beta is equal to minus b by a and alpha beta is equal to c by a, where a not is equal to 0. Now I will explain how to find out alpha and beta. This is roots of the quadratic equation and their characteristics. This is our general expression of quadratic equation: x square plus bx plus c is equal to 0, where a, b, c are belongs to real number set and a not is equal to 0. If we multiply both sides of equality by a, then a square x square plus abx plus ac is equal to 0. So we can write down, if we add b square by 4 both sides of equality, then this section, this left hand side will become a perfect square. So if we take a square root of both sides, then this ax plus b by 2 is equal to plus minus of this b square minus 4ac by 2. So if we transfer b by 2 here, this is simplification. Then ax is equal to b minus b by 2 plus minus root over b square minus 4ac by 2. So x is equal to if we divide both side by a, then we can this minus b plus minus root over of b square minus 4ac divided by 2, this. So there are two roots. If we can denote them alpha and beta. This is alpha, this is beta. Okay, now these two roots alpha and beta may be complex or maybe real number. Now when these two roots alpha and beta will be complex or real, if b square minus 4ac greater than is equal to 0, then these roots alpha and beta are real number, and if b square minus 4ac less than 0, then these two roots alpha and beta will be complex number. Here b square minus 4ac is denoted by d, and is called the discriminant of the quadratic equation. Okay, now I will explain them very well in detail in next page. Here, result 1. If b square minus 4ac is equal to 0, then obviously d is equal to 0. If d is equal to 0, then these two roots of the quadratic equation will be same. Alpha is equal to beta is equal to minus of b by twice a. Okay, now result 2. If b square minus 4ac is a positive and a perfect square, then b square root over of b square minus 4ac is a rational number. So two roots alpha and beta will be rational and they are unequal. Okay, result 3. If b square minus 4ac greater than 0 and they are not perfect square, then two roots alpha and beta, they will be irrational and unequal. Okay, and result 4. If b square minus 4ac less than 0, then d obviously less than 0. So two roots alpha and beta will be complex number. Okay, and we can say that b alpha and beta both are the conjugate of each other. We can write alpha is equal to conjugate of b, or beta is equal to conjugate of beta is equal to conjugate of alpha. Okay, now I will then there are some examples related to this theorem. This example 1, solve this quadratic equation using the general expression for the roots of the quadratic equation. For using the general expression for the roots of the quadratic equation, we know the general equation for the roots of the quadratic equation, this general equation, and general roots, this alpha and beta. Now if we compare general equation and this given equation, then we will have a is equal to 2, b is equal to minus 4, c is equal to 3. So if we put the value of a, b, c in alpha, we will have this. If we simplify this root over under root is negative, so this is complex number, because we know I is equal to minus root over minus 1. So alpha is a complex number. Similarly, if we put the value of abc in beta, then we will have this beta, then this under root is negative, so this is a complex number. So we will have both of alpha and beta are complex number. Okay, similarly there is another example. This is example number 2. This is our given equation. Now we have to solve this using the general expression of the quadratic equation. We know general equation of the quadratic equation, general expression of the quadratic equation is this, and general roots is this and this. So if we compare general equation and our general equation and our given equation, then we'll have a is equal to 25, b is equal to 30, and c is equal to this. If we put the value of alpha here, value of abc in alpha, then we will have this is under root is negative, so this is complex number. This is our total alpha, this is our alpha. Similar logic, if we put the value of abc in beta, we will have this is this, and beta is equal to this, and beta since this is under root negative, so this is a negative number, this is the imaginary number, this is a complex number. So both of alpha and beta are the complex number. Okay, similar logic, you will be able to solve every problem of quadratic equation. Okay, these are the some quadratic equation, so you have to solve. This is this number 1, number 2, number 3. This is this. Solve this problem. Okay, if you solve this problem, it will be enough. Okay. So dear friends and students, if this video helps you even a little bit, give a thumbs up, leave your comment and share this video with all of your friends. Okay, until next video, stay well, stay safe, tata.